Welcome again to our UPM MOOC technical drawing for mechanical engineering. We are now in Module 4, Part Features. In Unit 2, Tangent Features. So, let's start with this unit. Real and apparent tangencies. A real tangency occurs if there is a surface tangent continuity. That is, there is no step, a smooth transition between the tangent surface. In this case, the size of the position of a primitive is not free, but dependent of the previous primitives described. The apparent tangency occurs when a contour is tangent to another, but there is really no continuity of surface. It's necessary always to represent these cases of real tangency. So it is necessary to show in a view of the tangency because the tangency substitutes a degree of freedom of the part. Otherwise, we will obtain a lack of information to describe the part. We are now to study the semi-cylinder tangent to box. In this configuration, without tangency, we need 4 dimensions. In this case, cylinder radius is free. But when the radius grows to become tangent, its dimension could disappear because the tangent relationship fixes this dimension. But in this case, the standard recommends us to place an informative dimension that we have to place in brackets. Two semi-cylinders tangent to a box. These frequent configurations correspond to tabs and grooves for multiple purposes. 4 dimensions and the view showing tangencies are needed. Tangent rod. This is the primal geometry for rods that connect 2 shafts. The first dimension is the distance between axles. The narrow end is dimensioned by radius because its angle is less than 180 degrees. The wide end is a diameter because the opposite reason to the previous case. It has more than 180 degrees. A sphere tangent to cylinder. This feature has 3 dimensions, 2 of the cylinder size and an informative one recommended by the standard. Only a view is required. Eliminating sharp edge. Sharp edge is a natural, logical consequence of manufacturing a part, but this produces problems. Sharp edge can be hazardous because of cutting. Sharp corners concentrate stress, and the pair between sharp edge and sharp corners make very difficult to assemble fitting parts. Elimination of sharp edge by fillet. A fillet is a tangent radius that rounds the edge or the corner. It is supposed to be tangent to the principal primitives, so its position is dependent and it's not dimensioned. Only appear the value of the radius, that is the only free dimension in this case. As how in all the cases of tangency, we need to show the view showing the fillet or showing the tangency. The very sharp corners must to be dimensioned in the original geometry, not in the rounded geometry. In some cases, we have found complex tangency. In these cases, the tangency relationships are complex to evaluate and to decide what dimension is free or which is dependent. So, in this knob, the torus being tangent to the sphere has its two radius dependent. It is placed as informative in brackets to make easy the understanding of the drawing. The conical surface has no dimension at all, because all his dimensions are dependent of the other that has been already defined. Let's summarize Module 4, Unit 2. What have we learned? Well, only real tangency reduces the degrees of freedom of elements. Apparent tangency needs to be completed dimensioned. The tangent feature representation needs the view showing the tangency in all the cases we have seen. Tabs, groups, rods are common tangent features. Fillets, as the most common tangent feature, are employed to eliminate sharp edges and corners. Some tangent configurations are complex to represent. We have finished Unit 2 from Module 4. We hope to see you in the next unit.